as a function of h. Write the volume as a function of h. Now, before you do that, I want to ask you a question about it. What in heaven's name would you want to be able to write the volume of that ice cream cone as a function of h? Somebody in your own words tell me, what purpose would that serve? What purpose would that serve?
But you could know how much water is in the cone based on how high the water is.
Do you hear what he said? You would be able to determine that quickly. If you've got this cone sitting out here like this, and you know the dimensions is 2 feet by 4 feet. You got a 4-foot high cone. It is 2 feet radius. You could do what? You could take a stick and stick down in that cone and pull it back out and see where it was wet from. And you would know from that information alone how many gallons is in that tank. How else are you going to determine how many gallons are in that tank? That's why you were asked to do this. So you come up here and you say, okay, let's solve this equation. Remember, this is a ratio, this is a ratio, this is proportionate problem. Ratio and proportionate problems can be solved like this. And it says that R is equal to 1/2 H. Now, what can you say that you've just done right here? You can say, I have written the radius as a function of H. I have written the radius as a function of H. You see this, everybody? So when I go back over here and I say, well, the volume of an ice cream cone is pi r squared h divided by what? By 3. That's cut in stone. You can't change that. So if that is the case, then look at this. That's r squared, right? Do you remember us finding that r was equal to 1/2 h? If I squared this side, I would square this side. I would get h squared over 4. So I could replace this by putting this as h squared over 4. So now I have pi h cubed divided by what? 12. Do you see what I've done? How many of you see? Some of you don't. It's time to go.